All right, thanks everyone for being here. Welcome, glad to see you here. My name is Justin Berg. I'm a faculty fellow in the research department, research office here. The VPR Mihalic, he couldn't be here at the opening right now. He was planning to give the opening remarks, but he had a meeting that just popped up that he had to take care of. But he will be here partway through and he'll give the closing remarks. But he wants to send his appreciation for your work that you're doing. He's excited to hear about your presentations. He'll get to see it later because we're recording these presentations. So the postdoc program, the seed funding program, it's been going for about 6 years now, and you are the 5th and 6th rounds of the program. And it's been quite successful, thankful to say. Some of the successes are, I'll give you some of the numbers, stats person, so I like to hear the numbers, but we have about 40 applicants who apply each year for these awards. And in total, it's been about 250 faculty of PIs, it's not including the co-PIs that have applied for one of these awards. And usually about 5 to 10 faculty PIs are awarded the seed funding each year. So over the 6 years, we've had close to 60 faculty members awarded. And it, as far as the costs go, in the 2 years for the 2-year postdoc, it costs the university about $1.5 million in total for that round of awardees. And so that seems a little bit high. Is it cost benefit to the university? And thankfully it is, because you are so productive. Those people who win these awards, it's amazing what you do. The average has been about $1.5 million to $2 million of external grant funding you bring in each year. So within that 2 years that you have your postdoc, it's been between $3 and $4 million of external grant funding that you're bringing into the university. So it helps, and it's exciting to see what you're doing. I get to read all the applications, so for my part especially, it's fun to see. The funding is also so it's supported by the VPR's office, but it's also supported by the provost's office and the colleges. They all contribute to the second year. So it's quite a collaboration among colleges and the VPR's office and the administration for these postdoc awards. And it's nice to see that kind of teamwork happening at UND. And we appreciate that support from the administration and from the colleges and deans and ADRs that also partake in, they help in reviewing the applications as well. So the topics that you will notice from today, they're quite varied in what faculty are researching. And so that's exciting too, to see the diversity of topics that is being researched here. And if we could share the collaboration, because it's more than just the PIs, right? We have the postdocs, and the postdocs are doing great work too. And we get to see that when you send in your research summary reports, how the postdocs have helped you and your research. So we're grateful to you as postdocs for coming here to UND and contributing your work and your effort and making an impact. It's exciting to see as well. And we appreciate you being here today. We know you're very busy, and those who are attending virtually, we appreciate your attendance. We hope that you will benefit from this, and network-wise, maybe have some research ideas brainstormed from some of the topics you hear, and to meet some of us. We're really open to work with you on future grants or future proposals, and we're open. So thanks again to everybody who's being here and those who've supported this process and this seed funding. And we will start it off with, the order is a little bit different because things change, as we know. So we're going to roll with the changes. Rayanne Anderson will start us off, and then Naoma, you'll be second. And then we should be following the order pretty much. Holly, she's going to come in later. She'll present at the last part of the first cohort, the first group. And then Ho Chi, she'll present first on the second group, and Brian, you'll go after her. and then the order should follow after that. So thank you, everyone. We'll let Ann start.
Doesn't look like it's forwarding slides. Here we go. Okay, thank you. Hi, everybody. I'm Rayanne Anderson. I'm in the psychology department. And the theme of our project was expanding the science of sexual violence to include marginalized communities in North Dakota. Historically, sexual violence research has really focused on college women and women in domestic violence shelters. Important high-risk populations, but those are not the only people affected by sexual violence. And in fact, North Dakota is home to many of the most vulnerable folks for sexual violence. So rural women and Indigenous women. So our goals for this year were 3: new data collection, grant submissions, and manuscript submissions. So I'll touch on each of those, mostly on the new data collection because that's what I'm most excited about. And bless my postdoc, Neely Gesser, who could not be here today, who's been really managing this data collection for the lab. So it's well established that about 25% of college women experience rape while they are on campus. One of the tricky parts of thinking about how do we reduce that risk and how do we promote recovery afterwards is that of those 25%, 50% of them will have already experienced rape before. So that rape on campus is a second, third, fourth assault. And prevention for somebody who is already traumatized is a little bit different, is a little bit more difficult. So that was our focus with this new data collection. Particularly, we were interested in the 1 in 6 college women who have been sexually abused as children, and how do we prevent further a new assault in adulthood while they're on campus. Why this all happens is unclear, but the hypothesis is that experiencing childhood sexual abuse and sexual assault during teen years, it interrupts typical development. And so you're not able to gain the protective skills that you might otherwise have. And we wanted to focus on interpersonal skills. So prior research has suggested that childhood sexual abuse damages interpersonal skills, which I think makes some intuitive sense that if you are harmed by an adult as a child, and adults are supposed to be protecting children, your ability to form relationships and how you think about relationships is going to be changed. Childhood sexual abuse also causes a lot of mental health problems, which then impart another type of vulnerability, right? If you are experiencing post-traumatic stress disorder or depression, harder time watching for threats, harder time actively responding to them. But we also really wanted to keep in mind dissemination. We could invent the perfect risk reduction program, but if it's too expensive or too hard to implement, it's not going to go anywhere. So we focused on things that could be delivered in a group and things that could be delivered by non-experts, but you wouldn't need to be a PhD to give this intervention. So what we did this year was develop and test a proof of concept kind of micro intervention to see, can we put all of these ideas together? Will people who've experienced childhood sexual abuse show up? Will they think it's acceptable? And then can we train undergraduates to be able to deliver this effectively? So we developed this single session intervention where people learn an interpersonal skill for refusal, and they learn therapeutic writing. So again, thinking like easy to implement, low cost, but tied to the mechanisms that we think cause this repeated violence. And we recruited 40 women who experienced childhood sexual abuse between the ages of 17 to 26 who participated. And 40 sounds like a small number, but we had to screen hundreds of people to be able to get to this number of people. We had to have a wait list of people who were interested. We had to have a consent session with them to make sure they could use Zoom, make sure they wanted to do this, and then kind of have all these people on a wait list and be ready to pull the trigger to get them into a group that was happening at 3 different times in the week. Shockingly to us, and this is one of our pieces of good news, though I wish I could claim I know why it happened. Our sample was really diverse. I'm not sure exactly which strategy for recruitment it was, but our sample that worked so well, but our sample was 50% African American, 10% Indigenous, and another 10% Hispanic and Asian. So very few white women participated in this program. It was really diverse participant sample. And our initial data suggests that people liked it. In spite of having to be on Zoom, in spite of having to do this maybe kind of personal thing with people they didn't know, people did really like it. And we coded video recordings of the research assistants who delivered this intervention, and they tended to deliver it with high fidelity. They did exactly what they were supposed to do. They did a good job of rolling with the unexpected things that can come up when you're doing a Zoom group therapy session during a pandemic. So that was we did that in 6 months, and bless Dr. Gesser for being the person who was in charge of the logistics to make this happen. I was trying for about 2 years to make this happen, and she did it in 6 months. So it is a huge credit to her abilities. Secondly, we wanted to work on some grants, and we submitted as a lab 4 grants this year. 2 kind of big ones, NIH grants. So one being a measurement focused one. This top one, this comes from my prior research. A big focus in our lab has been better understanding how we measure sexual violence. And I was invited to be on the national work group that is working on the standardized measure to do that. And as part of that work group, we submitted an NIH grant that, you all know how that works. We'll see what happens. Secondly, with Dr. Clinton Lizelle in education, she asked me to co-PI a grant she is working on related to how do we better serve marginalized students, particularly those who've experienced trauma histories, and the idea of trigger warnings, which I am personally not a huge fan of, but the data suggests contrary hypotheses. Some data suggests that trigger warnings would be helpful to marginalized students, kind of giving them a heads up that difficult content is coming and they have a chance to get their coping skills in place. For example, I lecture every semester about suicide. That's a really emotional, difficult topic. On the other hand, the way trigger warnings tend to be implemented is it tends to be implemented for only certain topics, and perhaps that actually reinforces stigma around those topics. So for example, I'm a scholar of rape. Rape is one of those things that tends to be given a trigger warning. However, murder is probably equally as awful, and rarely is that given a trigger warning. So there is some discrepancy here in what gets trigger warnings and why, and how does that relate to instructors who are trying to create an inclusive and positive educational environment. And then finally, we put in a grant I'm really excited about through the new Indigenous Trauma and Resilience Center on campus. 80% of Indigenous people experience sexual violence, 40% of them experience rape. It is, there's lots of unique aspects about rape against Indigenous people that deserve further study, and yet Indigenous people have been excluded, if not outright, implicitly from all major studies of intervention for sexual violence. So we don't know if those interventions work. We don't know if they're responsive to the needs. So that's the idea with this grant, is to work on building out what are the priorities for Indigenous communities in North Dakota for reducing the risk of rape and promoting recovery after rape, and having Indigenous communities give us some input on research methods and tools that we typically use to indigenize them, to make them more acceptable. And then finally, manuscript submissions. This is probably our weakest area. About 4 manuscripts Dr. Gesser has directly contributed to, either in terms of co-writing or just making the space so that I could write them. And a little sample, one being perpetration focused and trying to think about new ways to prevent perpetration of sexual violence. There are currently no empirically supported methods to prevent perpetration. There's a huge demand. I would love it to happen. It's not something we know how to do scientifically yet. And so we're in this push-pull of, we want to give resources to those who want to reduce their risk, but actually if we want to prevent rape, we have to prevent perpetration. We don't know how to do that yet. Really relevant to the communities in North Dakota are the second and third papers of one measure we developed to better understand acceptability of sexual violence interventions. Getting back to that idea that previously everything's been done with college students. Well, what college students like and are willing to do might not be what Indigenous people like and are willing to do. And what is a standardized tool that we can use to bring to different communities to learn about that? And then another really interesting paper under review about religious coping after rape. And particularly, I imagine women in rural communities, their pastor might be their first point of contact for coping and finding resources after they experience violence. Learning more about that process so we can make good clinical recommendations. And going forward into the next year, we're going to be still working on the interpersonal skills intervention, building it out, writing a grant to do an open trial of it. Working on another grant proposal right now to extend a longitudinal data set we've collected. I want to get a lot more papers under review now that we've got this kind of first big round of grant applications under review. And then I'm a glutton for punishment. And of course, I'm still collecting all kinds of other data that I hope to have Dr. Gesser's help with. And so that is the whirlwind view of the UND Sexual Violence Prevention Laboratory. Thank you. We'll leave this here for the next person.
Okay, I will start because I know some people. Yeah, no, that's fine. I'm Naima Kabouche. I'm professor in the School of Electrical Engineering and Computer Science in College of Engineering. I am the director of the Artificial Intelligence Initiative. So this is not mine. Mine, yeah. Well, I will continue. That's fine if you don't find this. This postdoc, this is the first year, and this postdoc is part of a larger initiative. Like I said, Artificial Intelligence Initiative, what we call AIR Institute. And the objective of this initiative is to establish a center later or institutes of artificial intelligence that supports all fields, and involve many faculty from engineering, from UND overall, and from other universities. Did you find? No? You want me to send it to you?
No, I got it. I think it's my fault.
Okay,
Can I send in the right one right now?
that's fine.
Live TV.
So, like I said, the objective of this big initiative is to establish an institute or a center later that work with all faculty at UND and also other researchers from everywhere. So mainly this initiative is funded by the college and 1 year, I think, postdoc from VPR. Well, that's fine. So who has already used artificial intelligence here in analyzing data?
I have collaborators that do most of ours, but we don't have a lot of that, so I don't have that much.
For birds, I know
Birds, drone imagery.
drone and things like that to classify something or detect
Detect, classify, count,
everything.
yes.
How about you?
Yeah, I joined the AI Institute with Jerome every year, right?
Oh, yeah, yes, yes,
We actually use the AI to in order to classify the disease state.
yes, diseases. Right, it's very common. Who else has used machine learning, deep learning? Of course, Sririt. No one else? Well, yes. So which field are you working? Biology, yes. And you, the same? Earth system science. In fact, artificial intelligence is used everywhere, not only to detect, to classify, but to predict things that humans are not able to analyze and see the patterns. What is behind the? So, well, I can talk and then. So this is the object. Academia. Federal agencies like NSF are heavily, awarding big grants to establish artificial intelligence centers for different things. Federal agencies are calling also for things like that. Companies are very, very heavily investing in artificial intelligence. In fact, we don't realize, but they have been using this for many years. When you connect to internet and you surf, sometimes, you get some things that are related to what you are looking for without doing anything. Because behind there is artificial intelligence that look for things to improve the service they are providing or to detect malwares, attacks, everything else. So let me one. Okay, so this the AIR Institute, like I said, is covering all fields. Just a few are here. Autonomous systems, I work with Mark Askelson on autonomous systems, and we do a lot of things. Cybersecurity is one of the big initiatives now because all what is happening, war and, who doesn't get phishing attacks every day? Every day, you get these, you can, I have $1 million, 2 million, just give me your information. So attacks, cybersecurity is a big, what is going on? Okay, infrastructure inspection. Now we use, drones to inspect power lines, pipelines, and many things. buildings because it's easy, but we use also artificial intelligence to detect what a human cannot do. Biology, medicine, like we said, diseases, classify, detects, and so on. So all these are tasks under this artificial intelligence umbrella. And I have two people with me leading this initiative. We hired some postdocs and many students to work, not only with my projects or my colleagues' projects, but also work with other faculty to get some preliminary data, submit proposals, and everything else. Okay. What is this? Sorry. Okay, artificial intelligence. Most of people misunderstand what, it's not only machine learning to classify. It's very broad field that include many things. Fuzzy models that analyze things like human, so fuzzy. Optimization models that optimize parameters to get the best results. Prediction models to predict what will happen in the future. Probabilistic models and machine learning, deep learning, and all these things. There are many, many categories under artificial intelligence. And that's why, we need people to work together, because some experts have expertise in artificial intelligence, others have expertise in other fields. So by working together, they can achieve a lot of things. So machine learning, for example, use it to classify, to detect something and to classify, like diseases, breast cancer or Alzheimer. So we can know exactly if there is to detect that stage of the disease or predict it in the future. So there are a lot of models, and some are supervised learning. That means we train them and then we test them on unknown problems. Semi-supervised, that means half, and then unsupervised, that means we don't train them. Sometimes we don't have the information, but they are able, however, they are able to detect or classify. However, they are less efficient than the supervised learning. So, like I said, AI is used in everything, especially in industry now, gaming, chemistry. One thing about chemistry is, and materials that I didn't list there. Now, artificial intelligence is used to design new materials, new particles. It's because sometimes it takes 20 years to get a new something at the markets. So using artificial intelligence, it speeds up a lot the process. So some projects for this initiative that I'm leading, for now, we just started, it has been about less than 1 year. We are working on several projects, mostly funded. So for detection of diseases, Alzheimer, breast cancer, we have a lot of papers on that. Security of unmanned area system, drones, manned aircraft as well. We are talking on what happened when we have GPS, loss of GPS signals. You can drive or your phone, you lose the signal, then you have no way to know where you are going. And the cyber attacks that have been targeting USA the last several years, like, this power plants, what we call smart grid, 5G, IoTs. There are so many examples of threats that have been going on the last several years on USA. So these are examples of current projects that we are working on. And I will talk just very fast about this example of Alzheimer. How can we predict Alzheimer using machine learning or deep learning? So there are 4 stages of Alzheimer's disease, what we call cognitive normal, early mild cognitive impairments, where people start manifesting some symptoms and forgetting time to time, and then significant memory concern when they have more, they forget more, and they lose their ability, cognitive abilities. And the last one is when it's very severe, Alzheimer. This is just an example of project that can use machine learning. So here we use it supervised learning. That means we need database that we use is the Alzheimer's Disease Neuro Initiative. This include thousands of patient data and include also information from MRI, PETs, and CSF, and other things, all data about patients. So we use, for one example of that we have published, is using a deep learning. That means to see if we can predict years, what will happen in years. So this database has 10 years information, 10 years for the same patient. So we use it, and we compare different, these stages of the Alzheimer's disease. And we, as you can see here, the accuracy of predicting is over 90 most of the time. And here we use it, what we call the binary classification, that we are comparing to, we can use multi-classification to compare all or to detect all of them. But here we used only to compare 2 every time, but the accuracy is very high. So of course there are some small number of false alarm and misdetection, but the advantage is that we can see if someone has, can we predict in the future that this person will have Alzheimer. So by looking to different features in that database. So just an example for this. Since May, we have just myself. I didn't list my colleagues. I have 4 grants funded after June 2021. So they are here. Some I am the PI, and others are, I am co-PI with other faculty. For proposals, I think we submitted many, small, large, and we are still working on other proposals that will be submitted this summer. The initiative currently have grants from different sponsors: Federal Aviation Administration, UNDCM, which mainly support this initiative, NASA. We have 2 grants in that list from NASA. NSF, 1 grant about cybersecurity, and 1 about inspection that use inspecting bridges and other infrastructure using artificial intelligence. And we have, of course, we are working with the several companies, Harris, Batlink, and Northrop on some of these projects. So I didn't put the list of papers, just I think maybe about 15 papers so far, just during this initiative. And some are with status pending. So it's very active a group, and we are interested in working with everyone to target large proposals and large opportunities and progress. And that's it. Thank you. Any question? Okay, well. Still here, thank you.
Perfect. Hello. So, good afternoon, everyone. And, my name is Xuxing Wang from the Department of Biology, and I tell you our progress over the last year on behalf of my postdoc and Dr. Ling Li, and she's out of town this week. And can I move to next slide? Yeah, perfect. So as Justin mentioned in email, so I briefly share with you about these 4 aspects and a briefly introduction about Dr. Ling Li. And second, I will talk about a little bit about the proposal that we have been submitted and some of the proposals have been funded. And then I talk about a little bit about our paper that have been submitted and published. And finally, I will briefly mention one of the presentation that Dr. Li gave in the national conference. So first of all, Dr. Li is graduated from Central South University in China. She actually got a bachelor, master, and PhD all from the same university. And before she joined my lab, she was a visiting scholar at Thomas Jefferson University and our medical school as well. And so she joined my lab and became postdoc. And so Dr. Li actually played a key role in our own proposal submission. Over the past 1 year, we have been submitted a total of 15 proposals. And there's 5 proposals have been funded, 5 proposals is being pending, and 5 proposals is not funded. So all those proposals actually submitted to, largely in NIH. And so, of course, we have a DOD and SF, and by collaboration with PIs from, UPenn, Johns Hopkins, Duke, and St. Jude, University of Tennessee, and the Mayo Clinic. So also have a University of Oklahoma. So the 5 proposals we have been funded over the last year, and that is almost about $1 million to my lab, and including 3 R1 grant, and so one sub-award from NIH and 1 Dakota grant, and which is a kind of internal grant. And so there are 5 still pending proposals. I think most of the submit to NIH, including 1 P30 grant and 1 U01 grant and 3 R1 grant. So I should say those are largely through the collaboration from with other PIs, and those pending grant has the budget around $5 million. This is amount money to my lab, not the total amount. So we also have a 5 proposals submitted but not funded, which including my NSF Korea grant. I think I will resubmit this one during this summer as well. And so in terms of publication, and Dr. Li actually have been published 2 papers, and that also have 5 peer-reviewed published manuscript, either under revision or under review. And the first paper she published, she published her first author paper on Nature Communication Journal, which is a prestigious journal, as you know. This paper also has been featured by UND News, and for this paper she developed very cool tools for large scale proteomics analysis. And Nature Communication paper, journal actually has an impact factor of around 15. So the second paper she published with one of my undergraduate students, and on the BMC genomics. And so this is a teamwork from my lab, including undergraduate student Elisa and Dr. Lee and other lab member as well. So she also have a 5 paper either on revision or under review. And so one of the papers we collaborate with the Mayo Clinic, and this paper is published, is submitted to the Journal Experiment Medicine, and which this paper is under revision right now. And the second paper we collaborate with the UTHSC, and this is a paper has been submitted to PNAS, and also it's under revision. And recently, we just submitted another paper. Dr. Lee is also co-first author. And this paper we submit to Nature Genetics, top 1 genetics journal with impact factor of 38. She also has a 2 co-author paper and collaborate with my lab member. So this is submitted to the proteomics, and another one, this is submitted to the infection and immunity. So both are under review right now. So she also give a presentation on to the NIH conference, and which is a nationwide meeting, and she present what she have done on the rat brain. And of course, finally, I would thank you, this VPR post-associated funding program. Without this program, and I think we cannot have Dr. Lee, and of course, we cannot make such great progress and accomplishment. And also, I would thank you, my co-mentor, Prakash, and also finally, I would like to thank you, all my lab members. All right, thank you.
Justin, can I go ahead and share my screen?
Hi, Daisy. Yeah, if you could share your screen, that would be
Yeah.
great.
Are you able to see my screen? Yeah.
We're not seeing it yet.
I have already shared. Are you seeing that? No.
We're not there. We're getting closer, I think. There we go. We can see it now.
Well, good afternoon, everyone. My name is Daisy Salvaraj. I'm a research engineer at the EERC. Even though my title says I'm a research engineer, I'm actually a joint hire working across campus. I teach at the School of Electrical Engineering and Computer Science. I also lead a lot of different projects at the EERC. And most of our projects are related to distribution system modeling, hosting capacity analysis, hardware in the loop testing. And we are also working on projecting the electric vehicle infrastructure for the state of North Dakota. So I'm here to provide a little update on our postdoc award, and our project mainly focuses on electric vehicle charging using the smart charging mechanisms. So let me introduce my team. We are able to recruit Dr. Majid Marisa. So he's not joined us because of COVID, and then the immigration challenges made it hard for him to join us. So we are hoping that he would be able to join us soon. And he is currently working as a postdoc at University Grenoble, Alpes, France. And his expertise is on power electronics, power systems, and design of the microgrid and testing, which is very much useful for our project. And along with me, I also have Brad Stevens and Professor Hussein Solifer for supporting this project. And so in this project, we are trying to develop and optimize, validate, control algorithm for a flexible smart charging system using multi-agent system. So according to ARENA report, more than 1 billion EVs globally by 2050 and around 14 terawatt hour of energy would be either absorbed or provided to the grid, and more than 18 million electric vehicles on US roads by 2030, requiring 9.6 million charging ports. So the EVs can be considered as both flexible loads and decentralized storage resources capable of providing additional flexibility to the electrical grid, which could support the power system reliability and stability. But on the other side, unplanned or uncoordinated EV charging stations can negatively impact the grid operation. It could again affect the system reliability. Therefore, smart charging techniques are becoming very relevant for effective scheduling of EV charging, and I would say charging, discharge, and the grid services. So since our postdoc is not sit here, we have a research agenda ready for the next year. And we have a couple of items listed out already there. So the main goal of this project is to design and implement test smart charging EV strategies, EV charging strategies, and that will be based out on a multi-agent based control system. And the biggest chunk of work would be on testing and validating these services using the power hardware in the loop system. So historically, these, if you look at the literature, the multi-agent system based control system is very limited, and especially for the EV charging and smart charging of EVs. So what we are trying to do here is to bring in the hardware in the loop testing. So we would like to redesign the power hardware in the loop design, where we would like to bring in different controllers to test and validate these services. So our postdoc would be definitely contributing to this because his area of expertise is on the power electronic hardware in the loop testing. So definitely he would be contributing to this work. And also we are planning on submitting a couple of proposals to, one for the internal funding at a State Energy Research Center, the EERC, and we will also be going after DOE and DOD solicitations regarding the large integration of large EVs for grid support and smart charging of EVs. We have already started writing a couple of proposals, and hopefully we should be able to submit it this summer. And our postdoc will also be encouraged to present papers at IEEE conferences and peer-reviewed journals. So even though our postdoc is not here, he has already started working on literature review and come up with the initial simulation. So we are confident that we will be able to start off with the work and submit more proposals and papers in the next year. And we are already working with multiple utility companies out in North Dakota, like Xcel Energy, Nodak Electric, Cass County, and Montreal Williams from Williston. And this utility partnership will definitely help us our research work. And if anyone is interested in our research work, please feel free to reach out to me. Thank you.
Good, green light. We good now? All right, I'll try that again. I'm Susan Feligi in the biology department. I'm a wildlife ecologist. My postdoc is here, Dr. Javier Lenzi. And we're working on, as one part of my lab, this is just a piece of what we do, is expanding drone and other types of remote sensing and incorporating some AI into some of the technology we do for wildlife applications. I don't know which one of these is. There it goes. Okay, now I'm messing it up. All right, so just to give you a little background on that, I work in technology, but maybe we can't work the technology. So the first thing's drones are unmanned systems. Of course, all of us at UND hear a lot about that. It's a huge thing in wildlife ecology. It's picking up a lot of momentum. And my lab has done a variety of work to really set up a basis of background about how to use them, the different applications for them. So we've done work with behavioral ecology to explore how ducks, geese, polar bears, and a variety of other species respond to flights and different types of aircraft platforms. In addition to that, we've done work with setting up best practices for protocols and even publishing on it. And we've done a fair bit of collaboration on AI, which I'll kind of loop back to in a second. Remote sensing, though, is more than just that. A lot of people think about it maybe in terms of satellite imagery, but a lot of remote monitoring also is involved with wildlife by attaching different kinds of devices to animals. And small transmitters like you see here, this is a radio tag, can be used to determine everything from survival to movement to even physiological and biological rhythms that are happening within birds and other animals. Both of these things, whether you're using drones or satellites actually, or any other type of thing in that category of traditional remote sensing or remote monitoring, results in tons and tons of data. And in order to really address conservation issues in a timely fashion, you need some way to deal with all that data. And so I've had a lot of success with collaborating with computer scientists to do different kinds of automated methods with that. Maybe. Maybe not. Ooh, I think we skipped one. Okay, so the postdoctoral fellowship that I got that Dr. Lenzi and I are working on is to first develop a little more drone AI and remote sensing tools, further enhance different ways that we study wildlife using these tools, and then second, take what we learned and try to apply it. And so starting with I'm going the wrong way with this thing. Starting with the unmanned systems, they're super popular in wildlife ecology. They're thought to really reduce costs in relationship to other types of monitoring tools. Huge safety thing. The number one mortality cause for wildlife biologists is flying in planes at really low altitudes and slow flights. So much better to send something up there without a person for safety reasons. They provide really high quality data and information that you can get over repeated time and space that you dictate, which is something that's difficult sometimes when you're using satellite imagery. And they're thought to be less invasive in the sense of some types of things where you might be flushing animals because you're on the ground trying to get close to them. That's one way you might be invasive. One way we search for duck nests is we take ATVs and drag a chain between them. Not exactly gentle on the landscape or the songbirds for that matter that we don't like to talk about if we're looking for ducks. And so it might be a less invasive technique. That being said, drones are also being used to harass wildlife, which is the complete opposite thing of what you might think of as a less invasive thing. And so we're going to talk a little bit about that assumption. And then, as I mentioned, any kind of big data, when you're collecting lots of it, you need a way to be efficient with it. And so that's where collaborations to automate the process is really, really important. So to that end, I'll maybe get this figured out by the end, which direction we went. We had 2 specific projects where we already had data collected that Dr. Lindsay could jump into this and learn quite a bit about unmanned systems, how to use them, what are the wildlife applications of them, some of the literature on it. And so we asked a couple questions from existing data. The first is, how do wildlife respond to a fixed wing drone that was flown as we would be doing habitat surveys in collaboration with Theodore Roosevelt National Park and looking at large charismatic mammals. And then we also were doing work up on the Hudson Bay near Churchill, Manitoba. If you Google that, it's the polar bear capital of the world from a tourist perspective. Has lots of charismatic animals, and one of those is the declining caribou. And they happen to end up living right among the birds that I study. I'm normally a bird person, so we're going to talk about some mammals, which is a little different for what I do. But the caribou provided an opportunity for us to expand and extend what we were working on there. So let's start with the first one, developing drone approaches for the feral horses and bison. Right now, currently, the Department of Interior doesn't allow a lot of drone operations, or any for that matter, and especially if it uses a DJI product, which is the most common type of drone platform. And so we actually did this just prior to a lot of regulations coming out that prevented a lot of flights, because there's a lot of concerns about disturbing wildlife using drones. And so we went out there and we were working as a larger project in collaboration with some others to look at habitat assessments where the drone was actually being flown to look for invasive plant species and to map out prairie dog towns to figure out where these prairie dogs were. But they have horses, feral horses and bison there. And so they happen to be available, and we kind of opportunistically took the chance to study behavior at the same time. And what we found was that horse and bison do notice the aircraft, which is not uncommon. We've seen that with ducks, we've seen that with geese. They did alter behaviors such as vigilance. So that's that noticing the aircraft, feeding, traveling, resting. But they didn't do a lot of escape behaviors. It was all low risk type threats, suggesting it's probably not something that's causing them to, you know, lose out on a lot of energy or other things that would be problematic. Dr. Lindsay just got a acceptance with minor revisions in the journal Drones for this paper, and we're providing some new insights about and recommended guidelines for drone use in natural areas and large charismatic animals. Then we took the caribou that we were talking about, I was just talking about, and talked this side of trying to figure out how do we efficiently count things. So caribou are something, as I mentioned, that are declining. They're a problem and a challenge. So we wanted to improve some of our efficiencies and see if we couldn't recommend something to a park where generally a lot of people can't get into. So aerial surveys is a primary way to figure out what's happening on the landscape for these animals. And so to do that, we had collected some aerial imagery of caribou herds at 2 different altitudes. And we had collaborated with Travis DeSalle at Rochester Institute of Technology and one of his PhD students, who now is a faculty at the University of Puerto Rico, to work with an open repository that we uploaded our imagery in, and then we're able to tag that imagery. So we could say, this is a caribou, this is an adult, this is a juvenile. This is something that's actually an artifact. We actually had some that were artifacts of the mosaic and stitching, and said, well, that's actually not a caribou. It's an artifact of how we put things together. And then we developed models to, which we heard already about, AI and machine learning type approaches to count them. So far, comparing it to humans, we've got better than about 90% detections. And not only can we detect them, we can, which wasn't really surprising to us, but it was to figure out how to classify ages, which would help with understanding reproduction. That is just about ready to go out for publication. We're still in a few final things with our computer science team, but I hope we'll be close to that in the next few months. Now, talking some other remote sensing things. Bird collisions. We're at a school with big aviation program. We actually have one of the busiest airports right here next to us. In fact, it's ranked the 8th busiest airport some years, 12th. Sometimes it's even as much as the 3rd busiest airport in the nation. And that's because of our aviation school. Lots of takeoffs and landings. And birds pose problems there. As I mentioned earlier, I typically do bird work, and birds pose safety issues for aircraft. So as part of work that I'm actually doing at the Grand Forks Air Force Base that's similar, we're looking at trying to mitigate collisions and understand risk associated with these birds. And so one of the ways that we're doing it is looking at FAA databases where it's all recorded and we know where the strikes were, what species are most vulnerable. We're also looking at efforts that USDA Wildlife Services does at our local sewage lagoons. There's efforts to haze or move these birds out so that they reduce risk. And so we're asking questions about how that effort has worked. And then we're trying to understand how birds are moving in a super complex landscape here, where we have attractants all over the place. When you look at the airfields, we have the Air Force Base to the west. You have a whole bunch of conservation things in the middle, like Kelly Slough that some of you might be familiar with, or even on the other side of the base, Turtle River State Park. And then you come towards town, you have the airport itself, and then you have sewage lagoons, you have the city dump. All of these things actually bring wildlife in. And in some places, we're trying to promote that wildlife. And we're also trying to discourage that wildlife. So it poses a really complex landscape of trying to understand if you move the birds from one place, do you actually increase the risk? Because you're just pushing them somewhere else, making them someone else's problem, from airfield to airfield, what that looks like. And so to do that, we're using these miniature little radio tags and these automated towers to track and creating a network essentially to track these birds, their movement, where they get detected across that landscape. And that has led to a bigger project. So that was a funded one with the city of Grand Forks that we recently got that Dr. Lindsay and I are co-PIs on. We have another one that we have unofficial approval that we're going to get funded. We're just waiting on all of the government aspects of that to be an official thing, but we should be funded to then marry the things that I just talked about, which is using drones and using this tagging technique, put them together and ask a question about if we haze the birds with the drones. So instead of being minimally invasive, we're going to be maximally invasive. All right. Where do they go? What happens in terms of their movement? And so this award will give Dr. Lindsay actually another 18 months of support following our time on this particular project. So that's pretty exciting and coming down the pipeline. And then we have another one with birds that turkeys, wild turkeys, many of you are familiar with them. Some of them hang out here on campus. We have a flock that's right here. Turkeys are not native to the state of North Dakota, but somewhere in the history of North Dakota, a bunch of people thought it'd be cool to have turkeys here. They're a popular game species, something people like to hunt. Some people like to see them. Others, though, find them a very challenging species. If you walk around on some of the sidewalks where they reside, they leave messes. And for ranchers in Western North Dakota in the winter, when we have harsh winters, huge snowfalls like we saw here recently in our spring, they're feedlots where cattle are being fed, turkeys congregate. When they congregate, they defecate, and they also promote disease problems. It is creating a problem for ranchers in that they've actually been almost too much of a success story here in establishment in North Dakota and in certain places. So instead of using miniature tags, we're going to use bigger tags and try to understand where North Dakota Game and Fish, the regulatory agency, is going to move birds that are nuisance ones and put them out in areas where hunters can harvest them because they're a popular game species. But we have no idea what that means. We have little information about these turkeys in general. Do they survive? We moved them in January and February, and I don't know about you, but if you relocated me in January and February, I would struggle to stay warm and I would probably be hungry. So what does that mean? Or is that really a successful effort? And so Dr. Lindsay is co-PI on this project to evaluate these movements. And so using some of the stuff we're developing already with movement data, we're going to be looking at the movement of transported turkeys, home ranges, survival, productivity, some basic nesting phenology out of that. So along those lines, and this is just, like I said, one part of what we do in my lab and directly related to this postdoc funding, but Dr. Lindsay is now a certified Part 107 operator. He will be soon flying these drones to help us understand behavioral responses there. We've gained some experience in remote sensing for him, competencies in artificial intelligence and collaborations with our computer scientists. And he's going to serve as on the grad committee of 2 of our students that are helping with these projects that I've described, because it takes a village to do all that we do. For me, I don't know why that got cut off, but I'm really getting a chance to expand in remote sensing work. I've done a little bit in tagging, but I haven't had a chance to really expand that and managing those large databases. So Dr. Lindsay is providing the necessary help and background in that area. We have 1 accepted manuscript that I mentioned, that's the horse and bison, 1 in prep that are both directly related to this postdoc award. We have 2 officially funded projects that are both the turkeys and the city, and the 1 unofficially funded one that's coming down the pipeline by the FAA and the USDA Wildlife Services that will be with the Grand Forks Airport. And the other thing is it's now allowed me to collaborate with the FAA, the city of Grand Forks, the Grand Forks Airport, International Airport, and the USDA, and really expand on the work I was doing with the Air Force Base. So that's pretty cool in those ways. And we, like everybody else, have a bunch of partners that have been really important in this, and funding that plays a huge role. So that was a lot really fast. Thank you very much. I appreciate the funding and all the opportunities. This has been a great opportunity for us.
Public use like bridges, roads, airports, pipelines, railroads. So we do have a lot of options when it comes to funding agencies. Maybe one would be Department of Transportation, but NSF, Department of Energy, and then several administrations under the Department of Transportation are also there. Also, we've seen a lot of, or some RFPs, requests for proposals from Department of Agriculture, Environmental Agency, and other federal agencies. We are, so I am the director, and with me I have Dr. Minu Rabi'i from Petroleum Engineering as our one of our associate directors, and Dr. Frank Gio, Civil Engineering as another associate director. We also have Dr. Dalo Gadafa as a faculty associate, and Dr. Rajan Hu, who's also joining our, who's also been attending and coming to our meetings and have been engaging in our activities. So what did we do with the money? We hired two researchers. The first one, Dr. Mustafa Salari, he was hired as a research assistant professor. Started in February 2022, and the area of expertise included mostly smart transportation, so resilience in urban infrastructure, smart transportation engineering, network modeling, air transport management. And then Dr. Dayakar Lavadia was hired as a postdoc research fellow, started in January 2022, and his area of expertise includes composite material, machine learning, sustainable material, and 3D printing. So the idea behind these hires were for research assistant professor. We were looking to bring in a new capability, a research capability. And in my mind, the smart transportation, autonomous vehicles, I felt like at UNB, we're kind of lacking on that. Can't really pursue a lot of funding agencies that are about autonomous vehicle and smart transportation. And then with the postdoctoral research fellow, I wanted to hire someone who has several or multiple expertise. And then I hired Dr. Lavadia, which both of these gentlemen have been very, I would rate them as great researchers. Unfortunately, Dr. Solari has not been able to get his visa, so he's started working remotely. He lives in Canada right now. We're hoping to get him over here soon, but that has impacted his performance, of course. The initiative resources include, well, again, the funds come from PPRs and CEM. So we have salaries for the director and associated faculty that are included. This comes from CEM, College of Engineering and Mines. There's postdoctoral researcher salary that comes from College of Engineering and Mines, and then there's the research assistant professor salary that comes from PPR, if I'm not mistaken. I don't really run the numbers myself. I've been told that the funds are set up like that, and I didn't choose for postdoc to be funded by CM or the other way around. Anyways, then we have some material, some limited funding for material and travel. Using the material mostly will be used to generate maybe preliminary data for the next big grant or big proposal that the PI wants to write in our initiative. And travel is mostly for promotion. So I used some of that funding travel. I went to an international mass timber conference. That's another area that I felt like we need to see, because timber structure as a sustainable, well, relatively sustainable and recyclable construction material needs to be researched, and yeah, so we have these resources, and now we'll talk about basically what you've been sitting here to know, right? The money table. So I listed submitted proposals since we started, since we had postdoc and the research assistant professor basically. And there's one thing to notice on this table. Even myself have proposals that I didn't list because I didn't use the initiative's resources. So, and that's the case with all these other faculty that are involved in the initiative. So, yeah, so the proposal needs to be developed with some level of support from either through proposal development or the PI themselves are benefiting from CIRI or the initiative, or they use some of the funds of CIRI to generate preliminary data. So all I'm trying to say is that everyone submitted a lot more, maybe, but collectively using these funds, we've submitted 10 proposals, high quality proposals, in the past 4 or 5 months, and they worth more than $4.5 million, and hopefully we will get these proposals. And we haven't really heard back from any of them in the first one, the UAS guideline for UAS pavement evaluation, but we're hoping to hear from them soon and get these proposals to go and work on the other ones that you see here. So these are basically the ones that we have decided to go after this summer or develop this summer. There's probably more that I didn't include in the table for now, but maybe we're unsure about the program, the agency, or who would be the team that's going to be working on it. But there's a lot more to go. And of course, since we haven't really had any accepted or funded proposals yet, but there's not a lot of publications to talk about. However, here are some of the publications. The first 2 are done by Dr. Solari since he joined our initiative. I worked with Dr. Lavadia, and I included a couple of our students basically based on our preliminary data collection for these 3 research items here, as you can see. And then Dr. Rabi has another one that's related to our basically series to some extent. I think Dr. Rabi has two. Sorry, Minu. And there's a couple of other publications done by Dr. Gadafa that are basically similar in terms of objectives within the series initiative or the infrastructure initiative. So since I'm not there to answer any questions, please feel free to contact me any way you like. In my office, option 2, most of the time, and you can email me, call me, and let me know. Let me know if you want to collaborate. Let me know if you have ideas. Let me know if there's anything that you need to be doing. And thank you so much. And again, I want to appreciate EPR's office and CM's leadership support both of them for this initiative, and I'm hoping to make it hopefully very successful. Thank you.
Thanks, everyone. I have a microphone here, so we can have a little bit of time here for questions and answers. And again, then we'll take maybe a 5-minute break, come back, and we can do the second groups. But just to remind you who is here from this first group, we have Rayanne, Shusheng, Daisy, and Susan. So does anybody have, hopefully this is on. Okay, thanks. Anybody have questions for one of the 4 of them who are here right now? And I can hand you the microphone. And normally we would probably do it after each person's presentation, but things, as you can see, it goes long, so we're trying to combine it. But yes, Bo, thanks. Great, thank you.
I'm very interested in this using imaging techniques to monitor the wildlife animals, and I was wondering, do you make those drones by yourself, or just use some of the commercial ones, or you need to, like, what kind of technology is required for these type of applications?
Right now, all of it we're using off the shelf type drones. We've used a Trimble fixed wing. We've also used, that was one of the first things that we used, and then a lot of DJI Matrice series products for a lot of more recent things that I've been using. So all of it's off the shelf type technology and hopefully accessible to others, but there's a lot of limitations to that too.
For everyone, did your postdoctoral fellows find enough social and professional support in the department? And had your department had many postdocs before that? I guess what I'm asking is, when Mike gets here, is my department big enough? Is it already have the professional and social support that's needed? What do I need to plan ahead? Maybe this question is yours.
Put Javier on the spot.
Okay. Hello, everybody. I could say yes. In my personal case, well, I'm from Uruguay. I live overseas since 8 years ago. And sometimes it's hard to land in a new country, especially if you don't have this type of support with your lab mates and your boss. Well, I don't have words to thank Susan for her support in every aspect since I came here. So first of all, and I had many supervisors in the past, so I can do some comparisons, and this is one of, I think is my best job ever in life, not only because of the scientific aspects, but also the personal aspects that for me are very important. And having good lab mates and I mean, having good people around you in your working environment is very important. In my case, I was very lucky to have those here at UND on the biology department as well. And that's one of the reasons why we accomplished a lot of things in our work.
Maybe not directly responding to your question, because I have yet to get anyone to move here to hire as a postdoc. My postdoc is my second postdoc. My first postdoc was the first one in our department, was a graduate of UND, so different situation for her. My current postdoc, geographically limited, didn't want to pick up her kids and move them, so we hired her remotely. But we do a lot of team science and we really wanted her to feel part of the team. So we've actually been doing Zoom lab meetings all year so that it's easier for her to be part of the team. And then she comes out like 2 or 3 times a year for a long visit where we plan some big social events so that we do have some of that team building. So do you have any thoughts?
Yeah, I think, yeah, as a PI, we always encourage our postdoc to communicate with everybody, including PI in the department or the PI in the other college. Like for my side, we always encourage her to talk to anybody in medical school because we do the research all more relevant to the disease. So that's, but it's a little bit hard for past 2 years because this is during the pandemic period. So I think that's very important for everyone feel living in the family. And but as you know, Brian, you know, and Susan, you know, so our department is quite, you know, diverse, right? You know, you do always do the, you know, ecology. We are doing the, you know, disease. So yeah, I think it's important for postdoc to go out, talk to with everybody. You know, that's very important. All right.
Anybody else have a comment for that question? Okay, thanks. This microphone helps the people who are online hear our conversation and questions. Are there any other questions for this session? All right, thank you, everyone. We'll take a 5-minute break, come back at like 2:35, and we'll start with the next group. We'll start actually with Holly. She was supposed to be part of the first group, but she'll start with the second group first. Thanks. All right, welcome back, everyone. Thanks for staying with us. We'll have our next set. We'll start with Ho-Chi, and then Holly was able to make it here, so she will go after that, and then Brian, and then it will flow with, as you see on the page. So thank you. And then we'll do a question and answer session after this set as well. And then I'll hopefully the VP will be able to come back and give some closing remarks. Thanks again.
What am I going to do with this one?
You can either put it in your pocket
Or just hold it? Okay. And is this one? And this is the advanced, right?
I think pressing down goes forward actually.
Pressing down.
With the other one.
This one? Oh, okay. Oh, hi everybody. I'm Ho-Chi Zhen, and I'm from Aerospace School, and my department is Earth System Science and Policy. And I'm trained as an environmental economist, ecological economics. So it's a little bit different probably from this group. And some of you know me, some of you don't. So for this project, we are looking at the best management practice to enhance forage resource and particularly economic profitability in North Dakota. So the idea, well, I have to go first. I have to apologize because I have to pick my daughter, so I need to run. It will be very short. So the focus is we are looking at the grassland in North Dakota, and the idea is very straightforward, and it's appealing to both ranchers and their beekeepers. Because both livestock production and beekeeping, they have to rely on the grassland. And the grassland, particularly the quality and the quantity of grassland has been declining, mainly because of the land use changes and the changing climate. You can recall last summer, we have a very drought condition, and the ranchers are constantly struggling to feed their cattle. So the idea is because their livestock production as well as the beekeeping, they are the main components in North Dakota agriculture sectors. If we can bring these two parts together to come up with a best management practice that can be appealing and also can be economically sustainable for the whole state. So that's the idea. So the objective for these postdoc grants, we are looking at sustainable, particularly ecological and economic management practice to integrate the two components in their agricultural landscape. So for the postdoc, we are about to hire, and I'm just realized there's an issue with the salary, but we are going to overcome it. We want to conduct a pilot study to collect some preliminary evidence, and particularly to collect some information from the stakeholders, the ranchers, the livestock producers, the farmers, and the beekeepers, to see if there's any common mutual interest can be emerged from these groups, as well as what are their concerns. The current species being planted in the ranchland, and the beekeepers, what they are caring about their the locations, and how can we put all these elements together to come up with a plan that can make everybody happy. That's the goal. So the outlook is the pollinators, both wild pollinators as well as the managed pollinators, honeybees, has received a lot of public attentions, mainly because they supporting ecosystem services and producing food to the human diets and the quality of the life. So the postdoc grant is also in alignment with my other federal funded grants. With this environmental economics and ecological economics approach, we look at individual landowners' decision making and how they can change the land use and land management, and what's the consequence on their landscapes, particularly like pollinators, agro-ecosystem services, and also we have been in the past have looked at water quality and water quantities. So the current build on collaborations, we have collaboration with actually the postdoc is from NDSU, and we are working with USGS ARROS and their NPWRC centers, and their also the Grand Forks, the USDA NRC S office. So we are going to have this postdoc to build to interact with all those current existing collaborations and to pick up her research activities. We also have some previous established relationship with the North Dakota Rancher Coalition and their Beekeeper Association and the individual beekeepers within the North Dakota states. So this will be something to have the postdoc to maybe establish some meetings to collect opinions, conduct some preliminary kind of surveys to start their work. So target the future funding agencies. Well, of course, USDA will be the main agency that we are looking at, because this focus of the project can probably fit a couple of the programs that we are looking at: the sustainable agriculture system, because we have livestock, we have beekeeping, we also have farming going on, and there's sustainable agro ecosystems. Then with that grant, we have to focus on more on ecosystem services. And there's also, of course, pollinator health. And with there's other USDA regional funding we are looking at. The NSF, they have changed the names. Before it was human and natural integrated system. Now it's dynamics of integrated social environmental systems. But this topic would certainly be something that we can think about it. And there's also Department of Agriculture. In the past, they have provided the funding for pollinators. So we will look at that too. I have others. So the current status of this postdoc funding is we got the awards notification in January. And so we sent out the advertisement right away. And currently we have already finished the interviewing and the fly out. We invited our candidates on campus, and we are about to make the offer. And I'm going to see with the changing of the salary, is she still going to come or not? But anyway, so our goal is to have this project start in January, at the beginning of January. She's currently finishing up her the thesis defense in the NDSU. So that's everything I get.
Sorry, I have to hold it. Okay, can you hear me? Okay, all right. And you said down to advance, is that okay? Try to get this right. So thanks all for being here and listening, and I really apologize that I'm late today. And so I'll tell you a little bit about the project that I was going to have this postdoc do, or will have them do, and then tell you a little bit about my recent experience with trying to get a postdoc here. So our laboratories really focused on understanding the somatotropic axis, which is growth hormone. So it's a pituitary-derived hormone and how it impacts aging. We've been working on this for a very long time, and there's a lot of information regarding if you reduce the levels of growth hormone in a mammalian system, you extend life. And it also crosses species to flies and worms and yeast and things. If you reduce growth pathways, you extend life. So it's evolutionarily conserved. So this is just a little bit of background on growth hormone itself. So you start out with, average levels of growth hormone when you're a young individual, and then you hit about age 20, 25, and the levels of growth hormone start to decline in humans and in mice. And with this, over time, you get a decline in muscle strength, muscle mass. You get an increase in fat mass, and your insulin sensitivity or your ability to handle glucose declines.
So if there's growth hormone excess in an individual or in rodents, we found this accelerates aging. So it shortens your lifespan and it increases the incidence of age-related disease. If you administer growth hormone in humans, it causes all sorts of issues too, in terms of arthritis. It can induce cancer, diabetes, and a variety of other things. So that's growth hormone excess. So if you reduce it, as I was just mentioning, you can increase lifespan. And so that's what our lab focuses on. Do I point at you? It's not moving. I'm moving the down one. There's the up one, there's the down one, nothing. So I can just start telling you, we have a mouse model that has a growth hormone, a mutation in the gene that differentiates cells of the pituitary gland. And it results in, there it is, thank you. It results in these really small animals that it'll be the animal on your right. It's called an Ames dwarf mouse. So it has a point mutation in a gene. And so these animals lack growth hormone, prolactin, and thyrotropin. They're extremely insulin sensitive from the time they arrive as pups up until the time they die. So they maintain their insulin sensitivity throughout life, which is really important. They have an increased ability to resist stressors. If you just take cells from these animals, put them in culture, stress them with heat, with UV radiation, with UV or radiation, and all sorts of chemicals, they last longer, they survive longer than wild type. And the most important thing is that they live 50% longer, the males, and the females live almost 70% longer. So, excuse me, they're a little smaller. They're about a third of the normal size of a normal mouse, but they live longer and they live healthy. And so we believe that this reduced somatotropic signaling through the growth hormone pathway causes a change in the metabolism of these animals really early on. So it kind of reprograms their metabolism. And this results in a shift from those resources of amino acids that would be used to build muscles and various other aspects of growth. And it shifts those amino acids and other nutrients coming in towards cytoprotection, and it ends up causing disease or allowing disease resistance. So the postdoc that we were going to have come in, we were going to have them, we're starting to look at specific age-related diseases. And one of those is called non-alcoholic fatty liver disease. And so it occurs many times in diets that are high in fat. That's how you can induce it. And there's also some genetic factors that lend themselves to fatty liver disease. So we were going to use these growth hormone deficient mice to study fatty liver for a couple of different reasons. So the preliminary data we have is there's a specific transcription factor in the liver that's involved in lipid metabolism, and this transcription factor is really highly upregulated in these mice. They're using that particular transcription factor already in the clinic to treat fatty liver disease. We know that if you put these small animals on a high fat diet, like 60% fat, they gain weight, but their liver doesn't become fatty. They maintain their insulin sensitivity, and all their factors like pro-inflammatory factors all stay suppressed in the face of a high fat diet, which doesn't occur in a normal situation. So we've been tying low growth hormone into that, those particular changes. And so we have two studies planned. We have a hepatocyte culture study where we isolate the liver cells from dwarf mice and from wild type mice, and then expose them to oleic acid, which simulates high fat in the culture. And then we also have a second study planned, and we've done some preliminary data, where we take animals from the wild type normal animals and the dwarf animals and expose them to either 10% fat, which is what's in their normal chow, or 60% fat over 12 weeks. And then we collect tissues from those animals. So we really don't understand why. So we have a little bit of preliminary data for the postdoc to work with. We've done some RNA-seq. So we've looked at gene expression in the liver in animals that have been exposed to this oleic acid. And then we've also looked at animals that have been fed the high fat diet. And I don't know if this, yeah, it does work. So these are wild type animals, and this is fat vesicles or lipid droplets within the hepatocytes of the wild type animal on high fat compared to when they're on a standard diet. And these are the little dwarf mice that are also exposed to high fat compared to the standard diet. So they really process lipids very differently. And we believe this processing affects their inflammatory markers and a lot of different metabolic processes. So this is what we were going to have the postdoc work on. And this is just kind of a summary slide talking about these animals that are very small with high stress resistance, low cancer. They live longer. They kind of have delayed aging, whereas the animals that have this different lipid metabolism or normal lipid metabolism with growth hormone on board, they have lower stress resistance. They become insulin resistant. They have higher cancer rates, and that really promotes aging. So we're looking always at the balance between what drives aging, pro-aging processes, and what inhibits it. So the postdoc search, we got the award and we advertised immediately and started getting applications in and found one person that really exceeded my expectations in terms of their level of expertise with the liver. They didn't have a lot of expertise with the growth hormone or anything like that, but they were a liver physiology individual, and that was really exciting. So we had 3 qualified candidates, and I was just talking to Susan. There were others, but they got screened out somehow, and so ended up not in the mix to even interview at the time. But anyway, we found this particular, there we go. We found this particular individual, interviewed them, offered the position, she accepted, and then she couldn't get a visa application or a visa interview. So this was during COVID, and she's from Iran. And so we don't have an American embassy there for her to even go and interview. She said everybody goes to India. And so she tried to get, well, in Iran, that's typical. We have a lot of graduate students from Iran, and they all go to India to get their visa interviews, and things fly through, and it's not a problem. But she couldn't get an interview because all the embassies were closed due to COVID. So she tried 22 different countries to try to get an interview, including Mexico. And she finally got an interview in, so this was June or May. She got an interview in December set up in Dubai. So a week before the Dubai interview, they canceled on her and told her they would not reschedule. So it was really sad because she needed to move along with her life, and we needed to move along with all of this. So we ended up having to let her go, and she moved on to something else that was closer. And so I got permission to re-advertise. So it's currently re-advertised, and I'll find out at the end of the month. They'll finally give me the candidates that may have applied. So that's just my issue that I had. And I had NIH support at the time. I don't now, but we can scramble up some money somewhere for this postdoc to be able to do the work once we get them hired. So that was my experience. That's it. And next.
Okay, you didn't think you'd get through final exam week without one last exam, did you? Anybody have an answer for me? What, oh, I'm sorry, move that little. Oops. What rhymes with toil is a beautiful rich black that takes thousands of years to form, but it might disappear before we even know it if we're not careful. It's North Dakota's most valuable natural resource, essential for our future, and we're fortunate to have abundant quantities right beneath our feet. Any ideas? It's not oil, it's soil. This is the Williams soil, the state soil of North Dakota. And it's this for the top 20, 30 centimeters there is where you get that nice dark black molic epipedon, which is where you have so much of your organic matter and complex carbons bound onto your macro and micronutrients. And this is what gives our plants the fertility that they need to grow. And this is why North Dakota is on the top 1, top 5, top 10 lists for so many different crops that we have in agriculture. Unfortunately, that top 10 centimeters, sometimes 15 up to 20 centimeters has been shaved off in the last century due to a variety of wind, water, and mechanical erosion. We've lost far too many centimeters of that top profile. And so as a result, we have a variety of conservation programs that are set to ameliorate or prevent that. The title of this project is Soil Health Benefits of the Conservation Reserve Program. Myself and Dr. Catherine Yerkonis are the PIs. We're from the biology department, and we have a postdoctoral research fellow who is hopefully arriving the 25th of this coming week. So hopefully she should be here very soon. Samia Hamadi just finished up her PhD at Kent State University. She'll be joining us very soon. The Conservation Reserve Program is a federally funded program that delivers funds to landowners and producers to take their land out of crop and put it into a fallow, seeded into fallow. And these contracts can be 10 to 15 years long and can be re-enrolled. And so you're basically putting land out of production into fallow land for several decades, several years, several decades, and then putting it back into crop. The USDA, this is funded by the USDA. They have done a variety of studies looking at the benefits of this system on pollinators, wildlife like ground nesting birds, pheasants, ducks, but never a systematic evaluation of the soil health benefits. And that is what they have asked us to do. So they've asked us to find 220 sites across the Conservation Reserve Program. These are the sites that we have found, over 220 sites in the majority of the large block grassland sites. There's also other sites, forest and wetland. We're mostly looking at the large block grassland sites. And we have sites in a 35-year chrono sequence of time since enrollment in CRP. So we have everything from just recently enrolled into CRP last year or this year, all the way up to stuff that has been enrolled since the beginning of the program 35 years ago. We visited these sites last year. We're gearing up to visit this year, 2023, and also 2024. So we'll have 4 years of having visited these sites in the chrono sequence. And we will be measuring above ground vegetation, collecting soil samples, bringing those soils back, and measuring a variety of soil health metrics. Some of them you're probably maybe familiar with, things like carbon, nitrogen, phosphorus, macronutrients, micronutrients, the fairly typical things that you might measure in soil. But others are a little bit new to the field of soil ecology. Things like water infiltration, aggregate stability, and then a variety of biological metrics, which is sort of the keystone of our lab in the ecology department, looking at the bacteria, fungi, protozoans, nematodes, actually sequencing organisms in a way that we've never been able to before using molecular tools. Here's looking at the field work. Anybody recognize where the left-hand picture was taken? Baseball fans, Field of Dreams near Dyersville, Iowa. So I don't believe they were actually taking a core at that point, but they did have a field site that was close to Dyersville, so they thought they'd go on up there. And then we bring it back into the lab and have a variety of lab assays that we perform on those samples. So we have a variety of field and lab measurements that we're taking to assess soil health. Probably the most challenging one, though, is the biological assays. And so that's what the postdoc was sort of really designed to help us out with. That's the most technically challenging and most time consuming. So the postdoc will be arriving soon. They'll help coordinate some of the summer soil receiving and initial processing. help to conduct some field sampling if needed, if we need more folks on the traveling crews. And then the main one will be analyze, interpret, molecular identification of soil biota. And then, of course, drafting manuscripts for publications and proposals, project reports, maintain instrumentation and lab environment. And this takes a large team of grad students and undergrads, and the postdoc will be able to get to some mentoring experience with that as well. I believe that is it.
Good afternoon, everyone. My name is Deniz Fikri from Physics and Astrophysics. I am the copy of this project, and our copy is the Nuri Angel. He's also from Physics and Astrophysics. In this project, we will focus on thermoelectric and the tribologic properties of mainly two-dimensional materials. And for postdoc, actually, we are done with the interviews and we made a soft offer, but we are waiting for some official processes. Hopefully he can join us within summer, but I am not sure. So let me explain these two stuff. First one is the thermoelectric. This is some brief definition of thermoelectric effect. It's a conversion of heat, and it's a conversion between the heat and electrical energy. And if we have a conversion from heat to electricity, we have a Seebeck effect, and we have Peltier effect for the reverse process. As you know, we are producing enormous amount of energy every day, but we are losing about 70 or 60 or 70% of it as a waste heat. So how about get back some of this waste heat? And the thermoelectric effect is the one of the best way we can convert waste heat into electrical energy. So in this project, we will search for promising materials for the thermoelectric conversion. This thermoelectric effect is also useful for the deep space exploration. For example, here you can see the spacecraft, and it is powered by a thermoelectric effect. So the next one is the how can I move forward? Yeah, the next one is the tribology. Basically, we can say that it's a science of rubbing. And in this project, we will focus on the friction. And as you know, friction is everywhere. In some cases, it is very useful. For example, the friction between our tires and our rod is a useful friction. Also, during the winter, when we do this, we can warm up. These are the useful friction. But we also have bad friction. We can lose energy, and we can reduce the lifespan of, or for example, a mechanical system. In this project, we will consider two-dimensional materials. Here, this is the one example. These are called MXenes. In these MXenes, these are the layered materials. Within each layer, we have a covalent bonding. Atoms are covalently bonded. But between the layers, we have weak van der Waals interactions. So when we apply a force, we can easily move these layers on top of each other. And we will search for a best materials which have a low friction coefficients. This is the target of this part. So in this project, this is a collaborative project. We have computational part and the experimental part. In the computational part, we try to search, we will search the materials, and we will make some offers to experimentalists. And here we will mainly use the density functional theory. We will calculate the thermal conductivity, electrical conductivity, Seebeck effects. And in the experimental parts, we will synthesize some of the materials and we will characterize them. And we will make measurements using, for example, AFM. We can measure friction coefficients, also thermal conductivity, Seebeck effect, and we can calculate this ZT. This ZT is a measure of thermal efficiency. If you have a large ZT, this is good. And we are looking for ZT larger than 2 or 3. Here, this S is the Seebeck effect. This one is the thermal conductivity, T is the temperature, and this kappa is the, this is the electrical conductivity, this is the thermal conductivity. Our plan is to increase electrical conductivity and Seebeck coefficient and reduce the thermal conductivity. Yeah, that's all. Thank you.
Hi there, everyone. Are you hearing me in the room?
Yes.
Okay. Are you seeing the screen right now?
Yes.
Okay. All right, great. Well, it's nice to see everybody. Nice to be with you. Sorry, not there in person. COVID has come into our household and I'm a little bit under the weather. I'm glad to be here and I'm glad my co-PI Rob Simniski is here in the room. So our project is called Building Capacity to Research Rural Education and Workforce Development. What I'm going to keep this brief. We're going to introduce our team. This initiative that we proposed is in the College of Education and Human Development, situated in 2 initiatives that the college is supporting right now, one that I direct, one that Rob directs. And so we'll talk about each of those. And then I'll talk a little bit about our research priorities with this postdoc. All right, let me just make this nice and big. Okay. All right, so this is our team. There's me. I'm an associate professor in the College of Education, and I am the director of IREAD. I'll tell you more about what that stands for in a bit. I have my colleague Rob, who was interim ADR and is now stepping in as our associate dean for research and faculty development. So we're really fortunate in the college to have him there. He's the director of BEARS. And then our postdoctoral researcher is Caitlin Brecklin. And we had really hoped she would be able to be with us today, but she's actually defending her dissertation today. Caitlin is at the University of Wisconsin-Madison and has a really terrific expertise in rural education. So let me talk a little bit about what IREAD is, and then we'll sort of contextualize how this fits with what we're proposing to use this postdoc for. So IREAD stands for the Initiative for Rural Education, Equity, and Economic Development. And it's really a research collaborative, a partnership between faculty across the college and our advanced doctoral students and folks across the state right now. So folks in DPI, local leaders, school board members, and even teachers. And there are kind of 2 core premises of IREAD. And the first one is that public education is a critical social good that's impossible to separate from the physical and mental health of a community, from economic development and social justice. So we're really thinking about education as much bigger than what happens in a single classroom. And then the second piece, which seems kind of so simplistic, but it's that research is useful. And so we're really pushing back against this idea that as researchers, we just publish for other researchers in academic journals that folks who are actually doing the work may not ever actually engage with. And so our products through IREAD and with this postdoc are always geared in sort of 2 ways. There's the academic publications and the presentations, which Rob and I do quite a bit of, but then also that kind of public engagement piece. So policy briefs, memos, white papers, things like that, because our partners are really interested in the research, not just for the sake of research, but they're hoping that it will help them do something, either get more resources for their school or try a new initiative or something along those lines. So that's an overview of iRead, and I'll turn it to Rob to talk to us about BEARS.
Yeah, the Bureau of Evaluation and Research Services is sort of a research for hire office within the College of Education and Human Development. It's actually been around for quite a while. It was developed in 1964, but under a different name. And then we sort of came out of hibernation, if you like that pun, in the last couple of years. Sometimes that kills, sometimes people just don't really like it. And so we've re-envisioned it to be a much more collaborative office within the college, where we have faculty fellows who we use to offer research services both outside of the university and within the university. And they supervise graduate students in order to complete this work. So it serves as a training module as well. We offer services in any of the social sciences and domains relating to education and human development. And we're really fortunate to have this nice collaboration with iRead, because it really serves both of our purposes, which is both external outreach to provide research services, but also internal support for research initiatives and grant seeking within the college, which iRead is an initiative within the college. So I'll pass it back to Diana to talk a bit more about the postdoc specifically.
Thanks. So our research priorities and initiatives over the next couple of years really center on the broad themes that I talked about with iRead, and then also what Rob was talking a bit about. But, you know, generally speaking, right, there is consensus of the value of education, and this is true everywhere, particularly public education, but it's especially true in rural areas. We know that schools, public schools, serve important social functions. We know that they are bringing resources to areas that don't always have other resources, nutrition, mental health. These are just some examples of many. You know, I think I always like to point to, you know, the case in North Dakota. Before North Dakota was even a state, there were about 1,400 schools, many of them one-room classrooms or schoolhouses across the landscape. So there's always been this recognition that schools are about more than just teaching kids how to read or add or something like that. And so, as important as though these schools are, they face a range of challenges, and many of these challenges center on different types of resources. So either they don't have the resources to offer breadth of curricular offerings that are competitive with what bigger cities are offering, but there's also resources around the workforce, like not having enough teachers or school counselors. And that last bit is really the part where we're situating most of our work over the next couple of years. The College of Education really is investing in this area of teacher retention and recruitment, particularly teacher shortages. And that's someplace where we're really trying to contribute. I have expertise in that area. And so much of our funded work is going to center in that. I already have some Spencer funding that centers on that project. We have other projects right now working with rural districts across the state, looking at teacher recruitment and retention, really trying to come at this from the approach that we can't really generate meaningful solutions until we fully understand the problem. And one of the things we're really trying to conceptually push back against is this idea that rural education is either, you know, one, urban education light, or that rural education is somehow one size fits all. And so a lot of our research initiatives are trying to really highlight the diversity of rurality and how that translates to different needs across the board. So that's what we'll be working on. Caitlin is joining us July 1st. We'll have much more to say as we really dive into this, but I'll leave it there for now. And I think we're just at about 5 minutes. All right, thanks everyone.
Okay, hello everyone. My name is Bo Liang. I'm from School of Electrical Engineering and Computer Science. And my project title is Optical Dissection of the Stratal Pathway Dynamics. And I didn't push that. Yeah, okay. And the behavioral flexibility, my co-PI is Dr. Sobo Lei from Department of Biomedical Sciences. And we are looking for a postdoc, but I still haven't got decided that yet. Hopefully we'll find good candidates soon. So today we're going to talk about a little bit about the background, and I'll kind of specific talk about the approach we're going to use for this project, and a brief overview about this project as well. And we actually concern the brain. We want to understand our brain, and the issue is that there's kind of large variety of brain disorders. And from the data in 2016, it's actually neurological disorder is leading cause of this disability, and actually second leading cause of death. And it's a huge problem. And we have better means, approaches to recognize, to identify these kind of neurological disorders. And but we do not have a magnetic understanding of the brain. That's the issue. And this is something we are interested into, basically using some of the approaches to try to understand the brain fundamentally, how the brain works by principle. And what, as you can imagine that you can use some other approaches like a genetic approach and building physical models to understand the brain. But here, what we want to do is to use optical imaging to record the brain activity and in live animals. And as if you know that there's the brain contains of these brain cells. There's hundreds of billions of cells in human brain, and even by these animal models we're using, they have like hundreds of millions of cells. And how to record them all together is not possible. So we basically only record a few dozens or to a few hundreds of brain cells activity to try to understand how their relationship to the behavior. So here from this video, you can see this is a image of the brain signals, and from the brain region called prefrontal cortex in this little animal. And while this animal is moving around and doing this lever pressing and get the food reward. So that's what we are going to do is to use this miniaturized microscope we developed to basically record the brain activity and while the animal is moving. So that's what we, this basic approach for this project. And as you see from this, maybe I have this laser pointer somewhere, sorry. This little blob here represent the activity signal of a specific brain cell, and the brighter those blob, meaning that the more active those neurons. And from here, you can see that there are basically hundreds of neurons within these recordings. So that's, and we have this jargon here. We call this type of brain recording calcium imaging, because it's basically we translate the electrical signal to the optical signal as indication of the calcium concentration inside the cell. So that's basically the basic approach. And move on. And so if you look at those data, is very complex. You have a bunch of neurons and the very complex animals' behavior, and how do we understand their relationship is also very challenging. And you may kind of trying to basically we are using all sorts of approaches to really understand this data and to build the link between the neural activity and the animal's behavior. So the basic approach is that Imagine we have these brain signals we recorded from the animal's brain, and we have some observation of the animal's behavior, for example, how fast they move. And we can find some correlation between these two. For example, some cells are always active when the animal is moving faster. And we can even do some use this kind of machine learning approach to predict the animal's behavior using the brain's activity. And but this is some correlation data. Is not kind of a correlation doesn't mean a causation, right? And we can build some hypothesis from it. But to really prove that this is kind of a signal that gives rise to specific behavior, we will need some causal data. So that's addition to the calcium imaging, we're going to use neuromodulation approach, where we call optogenetics, to modulate, either inhibit or activate certain type of brain cells to see how the behavior response, how it's going to change. And in the future, we're trying to directly kind of link the loop to use this closed loop modulation to modulate the neural activity based on the activity pattern, and to try to understand some kind of relationship between these two to get some understanding. So this is a basic approach, and the project we're going to do is to really identify the role of striatal circuit in the behavioral flexibility. So the behavior flexibility is something that very critical, its ability for us to adapt the environmental change. And for example, if you are driving in the United States and you can drive very well, if you go to the Britain, you may need to do some practice to be able to do it very good. And some psychiatric disorder, neurological disorder patient, they have this kind of behavioral flexibility deficit or cognitive flex. Some of them has this cognitive flexibility deficit. So what we are going to do for this project is trying to use a behavior model. We call it reversal learning model. We train the animal to press the lever, for example, the left lever, to get the food. And for a couple of days, they will learn it pretty fast. And we switch the rule. And the animal has to press the right lever to get the food. And for the normal mice, and they can do this pretty fast, and they learn this rule after that. But if we use some transgenic model that built for this, for example, OCD, obsessive compulsive disorder, they may not be able to do that. So we will compare those kind of a couple of groups and try to understand the neurological substrate of that behavior. And we are mostly interested in a brain region called striatum. Was previous studies, including mine, and found that they are more related to habit formation and behavior flexibility, etc. So this is the basic overview of this project. And we'll basically collaborate with Dr. Lei in medical school and have some external collaborators at NIH and other universities. And yeah, I want to thank the opportunity from the VPR office and for this postdoc funding, and my college and department, their support. Okay, thanks.
Hello, everyone. This is Frank Xiao. It's an interesting. I think after your presentation, I wish I could learn something about bioengineering. I think it's very interesting. It's nice to see today, to see the presentations from different areas, different fields, you know, like EE and bioengineering and biomedical engineering. Okay, this is Frank Xiao, and so this is my second postdoc award. So I will start with something related to, let me see how to go next slide. Okay, here we go. All right, so in the previous postdoc award, we have several paper published, including this one in ESNT, which is a top 1 journal in my area, I believe. And this is the water search, and this journal is very hard to publish in. They have very low acceptance rate. There's some other journals may have a higher impact factor than these journals, but I would never submit the paper to that journals because the reputation is not good. So this is a solid journal. It's very hard to publish it. And we just recently have another paper published in ACS journal, and which is selected as cover for the journal. Speaking about the grants, with the support from previous postdoc award, I got this career award, and also have award grant from Department of Defense, which is called limited scope project. It's phase 1, which may lead to $1 billion and for extended or multiple year project. And I just got the notice recently, have another DoD grant selected and approved from Department of Defense. We're talking about the federal source money is very hard to get. I'm not sure in other areas. In this area, in engineering, in civil engineering, environment engineering, the water rate is probably less than 10%. I attended previously in panel, I don't want to mention NSF EPA. The program director said, here are our proposals. I want 40 proposals. I want 7 or whatever proposal be funded. Okay, so I calculate that's less than 10% basically. So in my area, it's very hard to get awarded. So I'm lucky to get this support from VPR, and so can get secure the external grant. Okay, in addition to federal grants, have some graduate scholarships. So my focus today is about PFAS. So what about PFAS? PFAS are per polyfluoroalkyl substances. So we're talking about a very large group of chemicals. They're very useful. They're made by 3M and DuPont. Actually, they use like baking papers, non-stick cookware, and waterproof clothing. Very useful chemicals. It's been produced since World War II. But like many industrial chemicals, now they're everywhere, including in human blood samples. I don't have the slides here. PFAS have been identified in 95% of American blood samples. It's scary. 95% of Americans have PFAS in their blood, and the concentrations are much higher than any other organic compounds identified in American blood samples. So in the United States, I believe they're ubiquitously present in natural environment, but there so far they have been found hundreds, thousands places in the United States, and which has caused serious concern among the public. And the EPA plans to regulate certain PFAS chemicals next year, which is a big deal. It means every drinking water treatment plant, they have to follow the rule, follow the law, make sure their treated water has less concentration, less PFAS in their treated water. So the goal of this project is really to develop the treatment approach to remove this so-called forever chemicals. They are very stable to remove. So we use a low temperature catalyst thermal treatment to remove them from contaminated soil and GAC and firefighting foams. We have 4 objectives, including remove them from spent media, GAC, and TBFs, and soil and some other stuff. And here are our tools and approaches we're going to use. And this is our hypothesis. I believe this is our degradation pathways. We believe in certain places the catalyst can be involved, accelerate this degradation, which has been shown by, confirmed, actually demonstrated by our recent results. This is our timeline. I'm in the process of hiring someone. The position has been officially approved last week. So I started to receive some applications. So hopefully you can have this person here later in this year. Okay, this is my presentation. Thank you.
Good afternoon, everyone. My name is Xiaodong Hou. I'm from the Institute for Energy Study under College of Engineering and Mines. It's very nice to see some synergy between these topics and mine. My project is to develop an advanced battery for the UAS system. My background is mostly in chemistry, so my work is mostly on the battery side. So lithium battery now is not a new stuff, but these few years is getting much more popular than past few decades. Actually, lithium battery was first commercialized in 1991, about 30 years ago by Sony. So the original target is those consumer electronics, like your cell phone, your camera, your the laptop, because of lithium battery. So you have those very small smart cell phone. And now in the past few years, battery regain a lot of attention is because of vehicle, the electric vehicle. The very first company which make the electric vehicle commercialized and mass production is Tesla. So now you know the CEO and the main founder of the Tesla, Elon Musk, is becoming the richest person in the world just a couple of years from almost bankruptcy of the company in 1817, a few years back. And actually, there is another big application about battery is even the energy storage. Now we are talking about renewable energy, try to replace or significantly replace the traditional fossil energy. So then we are using solar cell, we are using wind. Those energy are not on-demand energy, so you need energy storage. So lithium battery could play a big role over there. So with that, well, the reason is pretty simple. We're Grand Forks become the hub of the UAS, so we're trying to see if the battery where we made it can have an application on this UAS system. And like all the other power system, like a vehicle, the dominant energy system, the power is still the ICE, the internal combustion engine, because you need a very high lifting power for those heavy UAS. We're talking about a few hundred kilogram, payload. But those power, the ICE engine are pretty heavy, noise, and very low energy efficiency. So you will find on those smaller, actually many years back, those batteries powered, were all electric powered UAS. They are using battery. So because the energy efficiency is very high and small, so you can design your UAS with a very small system. But even today, the battery cannot use a very large system because the energy density is still low. Even the best lithium battery has about energy density at 260 watt-hour per kilogram. So you probably can fly 30 minutes, on a single charge. So energy density is a major problem with the current lithium battery. That's bring to our research target for lithium sulfur battery, which on the roadmap of the Department of Energy for the battery development is the target for 2030. The reason is simple because you can see the energy density for the lithium sulfur battery is almost 10 times the current commercial lithium battery. And this in lithium and sulfur is a very cheap element, so you can bring the cost down significantly. So, but at the disadvantage side, the lithium is there's a chemistry challenge. So in the ideal world, the lithium goes back and forth between the cathode and the anode. So only only the lithium ion going back and forth. So this is a cathode, this is an anode. You have a separator, you have electrolytes. So, but when you use sulfur as a battery, as a cathode, and you play with this chemical reaction, so you get this lithium sulfide as the final product. During the charge and discharge, you are producing some intermediate compound, which is called lithium polysulfide. Unfortunately, those lithium polysulfide mostly are liquid. So you can see those liquid are dissolved in the electrolyte, which is also a liquid. Then those lithium polysulfide transport to the to the anode side. That's called the Shuttle effect. So because of that, you lost your capacity, you lost your cycling performance. Another two challenges is related to the sulfur itself, because sulfur is not a very conductive material. It actually is a very good insulator, and a huge volume change. So because of that, even now there's a very hard research area. I don't think that there's any commercialization going on. So our approach to address this challenge are from what we have been done for quite a few years right now. So my research group has been in the battery material development, especially try to develop some carbon-related material from lignite or North Dakota lignite. So a key product we extract from the lignite is called humic acid, which is a very good precursor for graphene, the best conductive materials. And the humic acid is the major organic matter of the lignite. So we are using that humic acid to try to make a composite, or we call a heater structure with as a TMD. Just now, I actually work with Dennis from the physics department on this part. This part, we're using these materials as a catalyst to deal with the shuttle effect. And on the other side, we are trying to use the same strategy to make a three-dimensional graphene matrix and try to use as a host for the sulfur, which to improve the conductivity of the sulfur. So kind of use these materials to solve this two problem. So eventually you're gonna get a battery like this. So you're gonna have a cathode materials sulfur in a carbon host, and then you have an interlayer. This is a catalyst to target the shuttle reaction, and then the separate anode. So that is our strategy. So current state of our project, we have a PhD work on this, and we work with Dennis. We're trying to develop an SF proposal. We actually submit a couple other white paper over here on this topic, and the postdoc we just send the offer, and then probably can come before August, maybe middle and July for the visa process going well. So yeah, this technical part I'm not going to talk about. Oh, okay. Yeah, that's everything about my presentation. Thank you. Everyone will do our question and answer session here, and then John here, which will get us some closing remarks.
Yeah, Bo.
Yeah, actually, I have a question for Holly. And for those transgenic mouse model, do you see any kind of behavioral differences than the other one? That they smarter or or you know?
We've done a few studies looking at memory, spatial recognition,
Yeah.
and then a couple other labs have also looked at some behavioral testing. Oh, sorry. sorry. No, so we've looked at some aspects of behavior in terms of learning and memory. And then other labs have looked at a few other aspects. And we found that the animals that have reduced levels of this hormone, they maintain useful levels of learning and memory in comparison to the wild type. So in wild type animals decline in their memory and their ability to learn new things, and the dwarf mice maintain. And then we've looked at grip strength and a few things like that, and they remain stronger than the wild type animals that lose strength with age. So they're somehow delaying aging and maintaining behaviors and biological stuff.
Even that is smaller, much smaller.
Yeah, it's interesting. Thank you.
And just to remind you, Naomi, sorry, is here from the first set. She missed that question and answer session. So if you have a question about artificial intelligence for her.
Yeah, so I have a question for Bo. And so I understand your device can detect the cell in the PFC. How can you detect the cell in the striatum or hippocampus? Right? How can you differentiate the cell from the hippocampus and striatum from the PFC?
Yeah, that's a very good question. Because of the time limit, I couldn't elaborate. But the trick is, first of all, we use this kind of genetic approach to be able to label specific cell based on their kind of cell types. For example, if you use transgenic animal, you use D1 mice, and you can label some of the neurons in the striatum. That's one example. And to access to different brain region, we use a optical probe, a lens that we need to implant into the brain region and to target that area only. And because the microscope, we only have a very small field of view, like 1 millimeter. So we need to have some optical probes to be implanted into the area we want to see to be able to image them. Yeah.
So you actually studied the hormone, right? And so I think that is leading to the information, and then the information. Why you actually look at the epigenetics about this pathway and about this particular mutation?
So you're asking why we're looking at epigenetics? Oh, because some other studies that we've done with these animals, we've shown that if you look at, if you just take liver from young and old in the normal animals and the animals that live a long time, there's huge differences in the amount of DNA methylation. So yeah, when you age, you lose methylation. With age, you become more hypomethylated across the board pretty much. And so these animals seem to maintain their methylation pattern well into old age in comparison to, again, the wild type animals lose methylation with age. So that's what we're looking. So the postdoc will hopefully be able to start doing some DNA methylation studies, looking at histone expression and a variety of different things in terms of epigenetics.
Other questions?
I have a question for Frank. Okay, I read recently that PFAS is the cause for many diseases because they are used in restaurants, fast foods. So is there any research to replace PFAS? Because destruction, as long as they continue using those papers, it will be the same problem.
Yeah, that's a great question. So the PFAS problem. PFAS were made around World War II. So EPA was established in 1971. So a lot of EPA rules did not apply to PFAS because they were made earlier. So people didn't pay attention until 2001. A group of researchers found PFAS everywhere now, and then even in human blood samples. Now a huge concern. To answer your question, the industry has been pushing to replacements to PFAS, but you never know. Maybe the replacement more toxic than PFAS. So there's a problem. While living in the world, people create a lot of things, very useful, very beneficial, but also have a lot and unwanted consequences. Mhm. Mhm. Yeah. Yeah. Yeah, this is a good question. EPA only right now target the water. Europe may have a more stricter rule than than the United States, but I think they haven't moved on to they have in around 2010. 3M and DuPont voluntarily shut down or phased out their production PFAS. But PFAS, the carbon fluorobonds are very stable. They were made to be strong. They're used for Teflon, firefighting foams. They're present in natural environment forever. They're called forever chemicals. Even though the production stops, the chemicals still there. And also in some other places in China, they moved the production from here to other places as well. So. Mm.
So I just had a quick question about the map that you showed. So it's really concentrated on the East Coast, like North Carolina and a couple other places up north. And then in terms of those were like blue dots. And then North Dakota had the purple dots that it was found in the water, or is that, no, those are military sites, right? So the other one was found in the water. So what drives that concentration that has been found like in North Carolina and the East Coast versus the military sites that you show?
I think the exposure is very complicated, the exposure to PFAS. PFAS can present in water, so people can expose to water. Right now, EPA want to target in water, but I think that that's really just one part of the problem. That's why PFAS are universally present in the natural environment, because in North Dakota, we don't have PFAS production, right? Factory, but these chemicals can transport, they have volatile precursors, transported with air. So my theory, I never confirm it. People expose some volatiles through their nose to lung, and then the precursors convert to this PFOA and PFAS, this primary PFAS in their blood sample. We did a study in published in last year. We use earthworm. We found the same thing that can transform in earthworm, but we didn't go beyond that because I think because the earthworm we don't need to apply for IBI approval. But if you do fish and mice, you have to do this, go through the very long process. So I did the earthworm, but I think we can do the same thing for other animals. I think we can find same things. So the water is really one problem. Another thing is the daily life, and they present in baking paper, even in the McDonald's fast food. You know why the oil stay in the food and not contaminate your hand, because they're coating inside the paper, wrapping paper, prevent the oil contaminating your hand. That's coating before, I'm not sure right now, before PFAS, the PFAS, yeah.
Maybe one last question if there is one. Okay, then we'll turn it over to the speaker.
This question is for Susan. Birds are a great threat to aeroplanes. It's a huge problem. Aeroplanes.
Yes.
So I had to go before you finish, but is there a method to scare them away or to?
Well, I actually talked about that. So we're using, USDA Wildlife Services does a lot right here at our airport and right at the wastewater treatment plant next to it with pyrotechniques. So they shoot things off, sound, they use lasers sometimes. So there's a variety of things like that. And then we're actually proposing to use drones to haze them. So go in and chase them using different kinds of aircraft that should harass them. But the question with that is, though, do you actually push them into the flight lines? If you get them up and flying around, you may just move them from the wastewater treatment plant to the other side of the airport and put them into Kelly Slough, at which point they're still going to get up and go. But you can't harass them on Kelly Slough without even a lot more permits and a lot more challenges. So yes, there are a variety of techniques. There's other deterrents that are used in some places, but they also lethally remove them as well. So that's another option. There are some. We're not proposing to use one like that. The ones that look like Raptors they have really short battery lives, and so they're problematic that way. You'd have to do some building of new drones, which you asked me about. Do I build or do I, and there's actually some things where the sounds when you have rotary actually can do better sometimes, and it depends on visual stimulation, auditory. Some birds will respond to the Raptors more, others less so. So it sort of depends on the critter.
Yeah.
So thank you all. What?
Did you?
I'm gonna, I came from the final class.
Did you not present?
You didn't get a chance to present yet.
How y'all doing? Can we stay a little bit longer and let one more present? Are you okay? Have at it.
Sorry, yeah.
Is this thing working? Oh, okay. And I think there's a microphone up there unless you want to use this one. Oh, here. Why don't we just use this one?
Oh, that's fine. Okay, thank you. It's not. Yeah, thank you. I think it's on. Okay. Oh, so I don't need this. Oh, yeah, you'll need it.
Yeah, this is for the people virtually that they can hear you better if you use.
Oh,
and
okay.
then that's to move your slides.
Thank you. Thank you.
If you press the down arrow, that goes forward. Yeah.
Down goes forward.
Yeah.
Okay. Thank you. Thank you. Okay, hello everyone. Sorry I'm late. Just came from the final of my class. Here, so yeah, this is the project title of the postdoc seed project. So development of biodegradable anti-cancer nanodrugs for cancer therapy. I'm Bing-Lin Sui from chemistry. My collaborator in this project is Dr. Colin Combs from biomedical sciences. Yeah. So here, this is a cancer cell, right? A notorious disease. We all know about that. So, well, I'm not a surgeon, so I cannot cut it off. But I'm a chemist. I can make a tool to kill it, and that tool here is drugs. And to make the drugs more powerful or say more advanced, we make nanopro drugs here. Yeah. Actually, after so many years of fighting against cancer, we have found so many drugs that can kill cancer cells, including these, but a lot more other, a lot more than those. But there is some problem with these drugs. See, they are all organic molecules. They can kill cancer cells, but they are not. Their solubility in water is not that good. That means, as we know, our body is an aqueous system. That means their water insolubility limits their applications, right? The other things, those molecules are also toxic to normal cells. As we know, the side effects of chemotherapy, right? The hair loss, vomiting, and fatigue, etc. So there must be a way to improve that, to circumvent those drawbacks of conventional drugs, especially those two systemic toxicity here and the aqueous solubility. That's why we make nanopro drugs. So far, we have so many different nanomaterials that can be used, or say that have already been tested for this purpose, for delivering drugs into disease cells. In my case, cancer cells. So they load drug molecules, the previous drug molecules, and then they enter the cancer cells and release those molecules in the cancer cells to kill them. Right. So although there are many
nanomaterials invented for this process, including all these, but they all have problems. Either one is they might be toxic, then that's the nanomaterials themselves might be toxic. That's the problem. Well, the second thing is most of nanomaterials cannot be eliminated by our body. So once they get in, they stay. Yeah, and the accumulation, the long-time accumulation will definitely induce some side effects that could be very serious. Well, among all those, the one at the center is called polymeric nanomaterials, and as implied by its name, that's the nanomaterials made of polymers. And as a chemist, I synthesize polymers, and I can design polymers with desired properties. And if the nanoparticles made of polymers that can be degraded in the body, we don't need to eliminate it, right? The nanomaterials themselves can be degraded into non-toxic small molecules, then the concern of biosafety will not exist anymore. That's what we want. So, well, based on that, the entire strategy for this project is shown here. So first we synthesize, or say we look for new polymers that can be degraded in a biological environment. So they are basically at least 4 properties this new polymer should possess. One, they must be not toxic. Second, they must be able to carry drug molecules. They are the previously mentioned drug molecule. 3, they should be able to be degraded into non-toxic small molecules in biological environment. And 4, they should have the capability of being constructed into nanostructures to make those nano prodrugs, right? So then after a series of steps, those nano prodrugs are created, and after administrated into the body, the nano product will accumulate in the cancer tissues and get into the cancer cells. Then they will release those drug molecules in the cancer cells to kill the cancer cells. And after that, after releasing those drug molecules, the nanomaterials itself will gradually be degraded into non-toxic small molecules, and those molecules will either be used by the body as a nutrient or be excreted out of the body. Well, anyway, either way, will give us no concern about biosafety. That's the general idea about this project. So just to make it quick, yeah. Thank you for listening. Yeah. Thank you.
Thank you. Thank you for that. Thank you all. I know it's been a long day. If you can just indulge me for a minute, because I really love this day when you all come here and present. So thank you for putting, what have we been here since 1? Well, you all have been here since 1. And thank you for being here. Thank you for presenting, and thank you for your work. I apologize for going in and out. I had a unforeseen issue I had to work on, and we finally got that resolved. But this is one of my favorite days. This is one of my favorite programs. It's been around since, I think this is our 6th year of this postdoc seed program, and I didn't start it, but I fought pretty hard to continue it, and I'm going to continue to, because the way it's been funded over the years has changed, and there's not as much funding as there used to be. And I really want, my basic thought is, what better way to enhance research and enable researchers' work than provide fundings to get another great researcher to join their team, even if it's a little bit, so, and new fresh ideas. So I love this program. I know everybody in here, it's a competitive process to get these postdocs, and you all work really hard, and you've all benefited. Some of the outcomes, we try to track the outcomes of this program. I get asked every year. I've been asked ever since I've been in this chair. I've been asked every year, what's the outcome? What's the ROI? What's this and what's that? And my basic argument is, if we can't advance our research by putting our best researchers, coupling them with a new set of hands, everything, I don't think we can do anything else. So I like this program, and every year we've done this. Justin, you've been around a couple of years. Many of you have been around this for a while. It's a great day. And so I'm sitting there thinking, and I've thought this beforehand, I was telling Randy Richards, who works for Senator Kramer, who was invited today. I was talking to him. He kind of likes what universities are doing. I was talking to him a few weeks ago because he had stopped by the EBSCOR conference. And I said, he said, it's fun listening to presentations. I don't understand much about it, but I really like listening to science. And so we invited him here. He had another appointment and couldn't make it. But I said, this is probably not to discount anything else, but this is probably the one event where we have such a concentration of outstanding high performing researchers in the room. And so I was thinking over the years, like I would like to make a bigger deal out of this, but also part of this program is I want very little expectations on you all to present, report, because I want you to do your work, right? I want it to be as easy as I want to facilitate it. So I was thinking there today going, God, this is so amazing. I don't understand half the words you all say, but it's so amazing to hear the work going on campus. We might have to have a big reunion, like a 6-year reunion, and have a serious event next fall or something about research. Anyway, the other thing I was thinking is we have limited time to interact, right? So I did previous life. I started a program, not that you would love to do this, but we developed a retreat program where my previous campus had a house and some grounds that was donated to the university. It was like 10 miles from town in the mountains. And so we organized this thing where we provided the opportunity for people to spend the night, but we didn't require it. But we spent, I want to say it was a week up there every day with a group of people from very different disciplines. The principle was, let's get this group to know each other. Let's have everybody talk a little bit about what they do. And then we carved out time for people to do their research. There wasn't labs up there, right? But if you had a proposal to write or you had something else to do, and then we had a system where we exchanged works among groups of 3. I worked with one of my colleagues was a social psychologist, and she said triads work better than any other group. And so circulated whatever work people were working on for comment and whatever. And the principle was you get someone that is outside of your discipline to take a look, either what you wrote or what you're trying to do, and it really can be constructive feedback. And so that program is still going on. And the benefit of it was you really got to know people, because we had barbecues, we had food, we had quiet time, we had people present, we had a workshop on, manuscript writing, we had a workshop on grants, stuff like that. We'd have people come in. So that's the other extreme of not putting any constraints on you for this program is really get the people together to know each other. And I'm thinking we got 6 cohorts of people now. Would have been really cool to do that. But anyway, I'm going to stop talking, but I do want to make sure you understand my office has helped fund these, but each of your deans have also helped fund these. And the last 2 years, because my funding stream wasn't what it used to be, I partnered with the provost partner. So last year it was Debbie Storrs, and then this year it was Provost Link to partner to fund this program. So I don't get credit for starting this. I don't get full credit for funding it. I just believe strongly in it, and this is just one of my favorite days. And again, I apologize for having to come in and out today because I really didn't want to. But thank you for your presentations. Thank you for responding to Justin with reports. The reason I ask you to report your progress is not because I'm trying to keep tabs on you. If we can't trust you all to do your research, we can't trust anybody. But it's so that we have some data when I get these questions about the return on investment on this program. That's why, and I like to talk about the things that we've accomplished with it. So with that, thank you again so much for sharing your work today. Hopefully you've learned about the work from some of the others, and maybe that leads to some follow-up collaborations. Keep doing what you're doing. Thank you again, and enjoy the rest of the day and the weekend. Thank you. Thank you to Justin and Naomi and Mike for doing all their work. Justin. carries a load.